Hello and welcome back to Math with Mrs. Becker. Today in Algebra 2, we are going to look at the second half of section 6.7, where we get to graph polynomial functions by hand. So first off, we'll just look at a few steps that we will need as we go through this process. Okay. Step one is we want to find the real zeros. So that's what we have been practicing like in section 6.5 and 6.6. We were finding all of the zeros. In order to do this, you will do things like the PQ method. You might use the quadratic formula, you might factor synthetic substitution tables. Okay, so we'll find all the zeros. Then we find the y-intercept. The y-intercept occurs where the x equals 0. Then we will plot all those points on the coordinate plane. Then we will make a table. So you're going to actually make an XY table so we can see what's happening in between all of those points. So back to like 7th grade math where you do XY tables, that's the next step. Plot the points from the table, then we'll add end behavior, which is what we looked at the first part of 6.7, figuring out which way the arrows go, connect all the points, and we're done. So here's just kind of a little step-by-step. I'm going to go ahead and just do this on a separate sheet of paper, okay? So if I want to graph this polynomial function, obviously, if you can factor, that's still going to be the fastest way to find your zeros. However, I can't factor this. There's 4 terms. If I look at the first 2 terms, I can take out x squared and I'd have x plus 4. There is no way to make this x plus 4. So what I need to do is the rational root theorem, that PQ method. P would be -6, Q would be 1. Because Q is a 1, your possible answers are the factors of the numerator. I can divide -6 by positive or -1, positive or -2, positive or -3, positive or -6. So now we have to start synthetic division within a table until we find one of these to work. So 3x's, 2x's, 1x, no x's. So I don't have to add in any zeros. 1, 4, 1, -6. So I'm just going to start off by trying a 1. I carry down the first term, which is 1. 1 times 1 is 1. 1 plus 4 is 5. 5 times 1 is 5. 5 plus 1 is 6. 6 times 1 is 6. 6 plus a -6 is 0. So that's awesome. So x equals 1, that's one solution. I have a degree of 3, so that means I need 3 solutions. This is a remainder. We don't do anything with it. Next to the remainder is a number, followed by a single variable, and then x squared. So now I have x squared plus 5x plus 6. When you have a power of 2, your options are to factor or do the quadratic formula. I'm going to check and see if I can factor first, because that's always the quickest. Are there 2 numbers that multiply to 6 and add to 5? Well, absolutely. 3 and 2. 3 times 2 would get me to 6. 3 plus 2 would get me to 5. So factored, this is x plus 3, x plus 2. Now to use your factors to find solutions, find zeros, you take each group separately, set it equal to 0. Now I solve. So if I minus 3, 0 minus 3 is -3. If I minus 2, 0 minus 2 is -2. So those are your x-intercepts. So if I start plotting this graph, on the x-axis, this is where I'm going to have points. So if I go to the right 1, 2, 3, and the left 1, 2, 3. If I go positive 1, so to the right 1, I have a point. -3, so left 3, I have a point. -2, so left 2, I have a point. The other thing that they want us to find is the y-intercept. The y-intercept occurs when x equals 0. So if I go back to the original, if x is a 0, this term would be 0, this term would be 0, this term would be 0. So all I'd have left is a -6. So on the y-axis, my graph crosses at -6. 1, 2, 3, 4, 5, 6. So this is -6. I'm going to go up 1, 2, 3, 4, 5, 6. This is a -3. This is a +3. So that's the first couple steps. We found all of our intercepts and we plotted them. Now they want us to make an XY table to see what's happening in between these two. So in order to connect these 2 points, do I go upwards, do I go downwards, and how far? So a point that's in between -2 and -3 is -2.5. To see what's happening between these points, I need to see what happens at -1. To see what happens between these points, I have to check 0.5. So you're making an XY table, picking a point in between each of our zeros. Now when you do this, you have to put these back into the original problem. So if I go ahead and put it into the first one, -2.5 to the power of 3 plus 4 times -2.5 squared plus -2.5 minus 6. So this is 0.875, so just a little less than 1. So in order to connect these 2 points, I need to go through the point that's in between them, so that way I know how high that graph has to go. Now if I change these to a -1, delete, delete, -1, delete, delete. You can just up arrow as long as you're really careful and kind of double check and make sure everything turned into a -1, I get -4. So in order to connect these 2 points, I need to go through the ordered pair, -1, -4. Now to connect these 2, sometimes, I know it looks like you just want to go upwards, but sometimes it'll go down first, sometimes it might go up here, so it's important to see what's going on in between. So I'm going to change all these to 0.5, 0.5, ooh, 0.5, make sure everything looks exactly how you want it. Ooh, -4.375. So if I go downwards 1, 2, 3, 4, and a little bit more, so I have to go through that point to connect those. Our last step, now it is time to add the arrows. So I look at the original problem to do end behavior. The leading coefficient, the number on the front, is a +1. Because this is positive, as x approaches positive infinity, as I go to the right, my polynomial has to match the sign of the leading coefficient. This is positive, so my arrow is going upwards. The degree, and this is the degree of the original problem, the highest exponent is a 3. So as x approaches -infinity, as I go to the left, my polynomial, because this is a 3, it has to do the opposite. So if this side went up, this side goes down. That is one question. Okay, so you're finding the zeros using any method we've covered. Find the y-intercept, xy table to figure out what's going on in between the points, and behavior to add the arrows at the end, and we're done. I have 2 more examples. I think I'm going to do 1 more, otherwise this video could get kind of lengthy. If you can follow these 2, you will be good to go. And the cool thing about a video is you can always go back and rewatch. Okay, so if I'm looking at this problem, there are 4 terms. If you could factor it, awesome, that would be the best thing. But if I go ahead and I try to group, I could take out 2 x's, I would have x minus 2. I can't make that x minus 2. So in this case, grouping is not an option. So in order to start finding my zeros, it's the rational root theorem. P is 6, Q is 1. Because Q is a 1, I'm doing all of the factors of the numerator. So I could divide by any of those values. Now to start finding zeros, we do synthetic division in a table. My numbers come from my original polynomial function, 1x cubed, -2x squared, -5x positive 6. Now we just start trying these numbers. I'm going to start off with a 1. Carry down the first term, which in this case is a 1. 1 times 1 is 1. 1 plus a -2 is -1. -1 times 1 is -1. -1 plus -5 is -6. -6 times 1 is -6. -6 plus a positive 6 is 0. So I do have one solution. I know that I'm going to put a point on the x-axis 1 unit to the right. This is a remainder, this is a number, this is x squared. So I have x squared minus x minus 6. I can factor this. Multiply, add method. If you could not factor, then here you go to the quadratic formula. Okay, I can find 2 numbers and multiply to -6 and add to -1. that's negative 3 and positive 2. So x minus 3, x plus 2. To use this to find the zeros, you take each piece separately, set it equal to 0. So here I add a 3, 0 plus 3 is 3. Here I minus a 2, so I have a negative 2. So if I go ahead and I start graphing this, 1, 2, 3, 4, I'm going to go 4, 1, 2, 3, 4, negative 4. So 1, 0 is to the right 1 because it's positive. This one is to the left 2 because it's negative 2. This is to the right 3. Now what we have to find is our y-intercept. If I put in a 0 for x, this would be 0, this would be 0, this would be 0. So y equals 6. So 1, 2, 3, 4, 5, 6. That's where it touches here. 1, 2, 3, 4, 5, 6. Okay, so there's the first part. We have all of the points that are on the x and y axis. Next, I need to have an xy table. So to see what's going to happen in between these 2 points, I need to put in a negative 1. To see what's going to happen between these 2 points, I need to put in a 1/2. To see what's going to happen between these 2 points, I need to put in a 2. And where you're filling those values in, you fill them into the original problem. So if I go up to the original, negative 1 to the power of 3 minus 2 times negative 1 squared minus 5 times negative 1 plus 6. This is 8. So I have to actually go higher than this point. That's why you can't just assume, hey, I connect. Because in order to connect these 2 points, we have to go through the point negative 1, 8. So this actually goes up before it comes back down. So that's why this table portion is really important. You can't just connect the points. You have to see what happens. Like here, I don't know if they're just going to connect. It might come down and come back up. So I go ahead, change all my negative 1s to 0.5 to see what happens there. A lot of this is going to be careful calculator work. Okay, at 0.5, my y value is 3.125. So if I go to the right half a unit, I go up 1, 2, 3, and a little bit. So to connect these 2 points, I need to go through this point. Now to see here, it's possible it could bounce up, it could go down. If it goes down, how far? So I need to change all of these to a 2. So delete the point, change it to a 2. Delete the point, change it to a 2. And I get negative 4. So in order to connect these 2 points, I need to go through the ordered pair to negative 4. So right 2, down 4, go through that point and we connect. The last thing we have to do is end behavior so we know where these arrows go. The leading coefficient, again, to the original problem. The leading coefficient is a 1. This is positive. So as x approaches positive infinity, as we go to the right, our polynomial is going to have an arrow going upwards because this is positive. Okay, now the degree. The degree is 3. 3 is an odd number. So as x approaches negative infinity, as we go to the left, our polynomial has to do the opposite side because odd degrees mean do the opposite. If this one goes up, this one goes down. And that is another example. Now when you look at the final one, just notice here, because this starts with the power of 2, you could start off right away by doing the quadratic formula. You would not have to do P over Q. You could do the quadratic formula to go ahead and find those zeros. So the 2 questions from our notes that are most similar to what you will be running into are the first 2. So again, if you need additional help, you can let me know for sure or go back and rewatch one of those first 2 examples. I hope you enjoyed graphing polynomial functions, and I'll talk to you soon.